Hello year 8s and welcome back to mathematics. In this next video we're going to be looking at the next section of this topic, and we're actually going to be looking at a short section on solving equations. So in today's lesson we're going to be looking at what equations are and how to solve a few simple one-step equations and two-step equations. So let's get started into today's lesson. So first of all, what are equations? Let's first talk about this. An equation is a mathematical statement with an equal sign that shows that two expressions are equal. So what this means is that an equation just involves a equal sign. So if you have a look underneath, we've got an equation. 2 plus 4 is equal to 3 times 2. And here, we've got an equal sign in the middle. So this is an equal sign that we need to include in an equation. What this tells me is that the two expressions are equal. So if you have a look on my left side of the equation, we have 2 plus 4. So this side on the left, we call this the left-hand side of our equation. We've got 2 plus 4. That is the expression on the left. And on our right, we have this expression, 3 times 2. That's my right-hand side. And what this equation tells me is that these two sides are equal. Now, if you do those calculations quickly in your head, 2 plus 4, that's actually 6. And 3 times 2, that's also 6, which makes this equation true. So the equal sign just tells me that the two sides of my equation are equal. I've got an expression on my left-hand side, and I've got an expression on my right-hand side. So this is what an equation is. It shows that two expressions are equal. The left-hand side is equal to the right-hand side. In mathematics in particular, what we want to do is actually we want to work with equations that involve algebra. We want to work with equations where we have an unknown value that we are trying to find the value for. And so underneath I'm actually building off of this. When algebra is involved, a solution to an equation is a value for a polynomial that makes the equation true. So our goal is to make sure that our two sides of our equation stay true. We want to make sure that it stays true, and what we want to do in particular is we want to find a value for our letter or polynomial so that it is true. And here we've got an additional note. The process of finding a solution is called solving. So let's say, for example, I've got an equation that looks like this. My example underneath is x plus 2 is equal to 10. X plus 2 is equal to 10. Now, if you have a look, we've got this polynomial, x. X is a letter, and it represents a number that I do not know. I don't know what the value of x is. But if you were to think about this, actually, if we wanted to find a solution, we just want to find, when you want to find a solution, we want to find a number where if we put it in the place of x, it would make this equation true. Now, you can probably think off the top of your head, actually, if I replace x with 8 plus 2, well, 8 plus 2 is going to give me 10. And so the solution, therefore the solution for my equation is x is equal to 8. This is my solution. If x is equal to 8, this makes this equation true. The left-hand side is going to equal to the right-hand side. Because on the left-hand side, I've got 8 plus 2, and that is equal to 10. And on my right-hand side, I've got 10, and so that is true. So this is what a solution is. A solution is a value for the polynomial that makes our equation true. What we want to actually look at is the steps of solving an equation. How do we actually go to find the value of x in these equations? And so here underneath, I've got kind of the aim and the main rule that you need to remember when you're trying to solve for an equation. So I'm actually going to just move this down a bit so we can focus on it here. Our aim for the equation. So our aim for equations is to make the polynomial the subject. Okay, by performing reverse operations. Those two things here I want to talk about. Firstly, what does it mean to make the polynomial the subject? Well, if the polynomial is the subject of the equation, what this means is that what we're changing the equation to is to make it look like x is equal to some sort of number. Or if your letter isn't x, it could be a is equal to some number. We want to have our polynomial by itself. The letter needs to be by itself. Notice here, it's by itself on one side of the equation. We want to make it by itself on one side of the equation. Usually, conventionally, mathematicians leave that on the left-hand side, but if it's on the right-hand side and it's by itself, that's cool too. The way that we do this is by performing things called reverse operations. What we want to do is we want to look at all the other things that are next to our pronumeral or near our pronumeral that prevent it from being the subject of the equation. And so once we've figured out what the things are near it, so what operations that we need to do, we perform opposite operation, reverse operations. So here, this is where we need to remember things like, well, addition and subtraction are opposite operations. If I add 2, for example, if I add 2, the opposite of adding 2 would be subtracting 2. So if I add 2 to something, so let's say I have 4 apples and I add 2 more apples. If I want to get back to the original, all I need to do is subtract the 2 apples. The other thing is that we need to remember is that when we do multiplication, the opposite operation is division. So for example, if I multiply something by 2, if I want to undo it or reverse that operation, what we need to do is we need to divide by 2. Okay, so these are the things that we're going to be needing to do when we are trying to solve equations. So our aim is to make our pronumeral, the letter by itself, on one side of the equation. And the way we do this is by performing reverse operations. Now, there is a golden rule that we need to remember for equations. That is, whatever you do to one side of the equation, you must do to the other side. So if I add 2 to one side, I need to subtract 2 to the other side. Or add 2 to the other side of me. So if I add 2 to one side, I need to add 2 to the other side. If I multiply one side by 2, I need to multiply the other side by 2. And by keeping these two aims and also this rule in mind, we can actually go and solve equations. So let's have a look at this example. This is the same one that we had above, where we knew the solution for x is 8. So the way that we would do this is I would have a look at this equation. Let's have a look. I've got x plus 2 is equal to 10. Notice here on my left-hand side, I have x, the pronumeral I want to make the subject, but I've also got this plus 2 term. So what I want to do is make sure that x is by itself. And the way that we do this is we want to get rid of this plus 2. Well, if I want to get rid of that plus 2, what's the opposite of plussing 2? The opposite of plussing 2 is minusing 2. And so what I'm going to do is I'm going to minus 2. But because I'm minusing 2 to one side of my equation, I can't just do that. I need to make sure that this equation stays true. So what I need to do is I need to subtract 2 from the other side as well. And so if I subtract 2 from my left-hand side, all I'll be left with is x, which is by itself, and the plus 2 and the minus 2 will cancel each other out. I reverse that operation. And on my right-hand side, if I do 10 minus 2, that will give me 8. And so here, I have solved my equation. I've made x the subject. Notice here on the left-hand side, x, it's all by itself. There's nothing else there on the left-hand side. And so here, it tells me that my solution for this equation is x is equal to 8. The other way, once you get the hang of this, you don't need to actually write this minus 2. And another way that people like to think of this is if you've got an equation like this, what we want to do is we want to move this plus 2 to the other side. And the way that we need to do this is, well, a reverse operation. If we've got plus 2 on one side and we move it to the other side, we actually need to change that to a minus 2. And so here, x is equal to 10 minus 2, and that will give you 8. So that's the way that we are going to be solving equations. Let's have a go at a few examples of this. So we're going to be looking at one-step equations and two-step equations. So one-step equation only requires us to do one operation, and two-step equation requires us to do 2 steps. Okay, let's have a look at these first 4 examples. I've got 4 examples here. Solve the following equations and check the solutions by substituting for a and b. So I'll show you that in a moment. Let's have a look at this first example. Okay, first example, example A. X minus 4 is equal to 16. I'm just going to move my mic for a second. Okay, cool. X minus 4 is equal to 16. Well, let's start off and just write this equation. What we want to do is we want to make sure that x, our pronumeral, is by itself. And so here, notice we've got this minus 4. We don't want that minus 4 there. So what we need to do is perform a reverse operation. What's the opposite of minus 4? Well, the opposite of minusing 4 is to add 4. So what I can do is I'm going to add 4 to both sides of my equation. And so here, when I add 4, I'm going to get x is equal to 16 plus 4. And so my solution is x is equal to 20. So that's how we can solve this fairly simple one. Notice on our left-hand side, we had that x minus 4. We don't want that minus 4 there. We want to just make sure that x is by itself on the left-hand side. And so what we had to do was we had to find the reverse operation. We added 4 to get rid of that minus 4. Now what we want to also do is check the solution by substituting. What we can do is, once we've gotten a solution, we can check whether or not the solution is correct by just substituting it back in, replacing x with the solution that we have and seeing if our equation is true. The way I like to do this is I'm going to go, okay, I'm going to look at just the left-hand side of my equation. I'm going to shorthand this to LHS, short for left-hand side. Now in my equation, on my left-hand side, I had x minus 4. So I'm just going to write here, x minus 4. What I'm going to do is I'm going to substitute and replace x with 20, the solution that I have gotten from my solving. So here I'm going to replace x with 20. So I've got 20 minus 4. And 20 minus 4 is 16. And if you have a look on the right-hand side of my equation, so this was my left-hand side. On my right-hand side, well, that's equal to 16. And that's actually the result I have here. And so here, my equation is true. The left-hand side of my equation is equal to the right-hand side of my equation. And so here, that tells me that my solution of x is equal to 20 is correct. Okay, let's have a go at the same things, but for the second one. So let's have a go at b. Now for b, I've got 8y is equal to 40. So let me just write down my equation here. 8y is equal to 40. Now, here, if you remember from earlier this year, we talked about when we see an expression like this, 8y. What are we doing? What's the there's a hidden operation between 8 and y. If you remember from when we did algebraic expressions earlier this year, if you see 8y or any number next to a letter, that just means that we are multiplying our number and our letter together. It's just 8 times y. And so here, we have got 8 times y. We don't want to have that 8 there. We want to get rid of that 8. We just want the letter y to be by itself on the left-hand side. And so what we need to do is we need to get rid of the 8. Well, how do we do that? What's the opposite operation or reverse operation to multiplication? The reverse operation is just division. So what I need to do for this one is I need to divide both the left-hand side and the right-hand side by 8. So I'm going to go divide this left-hand side by 8. And because I can't just do it to one side, whatever I do to one side of my equation, I need to do to the other side. I need to divide the right-hand side by 8. Now, one of the ways that we can write this is by writing it as a fraction. So I'm going to write here 8y over 8 is equal to 40 over 8. And so here I can actually cancel out the 8s and I'm left with y on my left-hand side. And on my right-hand side, when I do 40 divided by 8, what's 40 divided by 8? Well, that's just going to give me 5. So my solution is y is equal to 5. Once again, we want to actually check this solution. So for a and b, we wanted to check the solutions. The way we do this is we substitute it into our equation. So here I'm going to write underneath my left-hand side. My original equation I had on my left-hand side, 8y. So on my left-hand side, I had 8y. What I need to do is I just need to substitute y with 5 and check whether or not this solution is correct. Now just remember, 8y just means 8 times y. And so if I replace y with 5, this just becomes 8 times 5. And 8 times 5 is indeed 40. And if you have a look at my original equation, the right-hand side is 40. And that's exactly what I wanted. And so here, this means that my equation is true. Okay, let's have a look at the next two. Okay, last two examples for our one-step equations. Firstly, we've got a plus 5 is equal to 12. Now, a plus 5 is equal to 12. Notice here on my left hand side, I have the pronumeral a. We want to find the value for that letter a. But on the left hand side, we also have this plus 5. We don't want that plus 5 there. So what do we need to do? What's the opposite of adding 5? The opposite of adding 5 is subtracting 5. And so what I'm going to do here is I'm going to subtract 5 from both sides. Now, if you remember from up here, the other way that we can do it, so the first way, I actually wrote that plus 4 over here. What we're going to do instead is I'm going to move this over to the other side. This is another way that people like to solve equations. I'm just showing you a few different methods and you can choose which one you like. And so what I'm going to write here is, if I move it to the other side, that plus 5 is going to become a minus 5. That's the opposite operation or reverse operation. So here I'm going to have a is equal to 12 minus 5. And my solution is going to be a is equal to 7. Once again, you could have checked our solution. So our left-hand side is going to be a plus 5, and if we replace a with 7, our solution, we end up getting 12, which is indeed the solution, indeed what the right hand side is equal to. Okay, final example for one-step equations. This time I've got negative 2b is equal to 6. Now here, this is very similar to that other example in part B, 8y is equal to 40. Here we've got a number that's connected to my letter. But what's different about this one? If you have a look, this one also has a minus sign. So what we have to do is we not only have to divide by 2 to get rid of the 2 here, we need to divide by negative 2. And so here, if I want to make the letter B the subject, so isolate it and make it stand by itself, what we want to do is we want to divide both sides by negative 2. And so another way that we can write this is I'm just going to write that fraction here. I'm going to divide by negative 2. And so when I divide by negative 2, these two will cancel out. I've got b is equal to, well, 6 divided by negative 2. What I like to do is I just deal the numbers first. 6 divided by 2 is equal to 3. And I've got a positive divided by a negative. Positive and negative will make a negative. And so here, that is how we can solve this particular equation. Okay, that's for our one-step equations. What we want to also look at is solving two-step equations. So let's have a look further down the page here. Two-step equations. Now here I've got a note. When we're solving two-step equations, start with the term or number which is furthest away from the pronumeral. So we want to look at the thing which is the furthest away from our pronumeral and then work backwards. So let's have a look at these two examples. Example 2, find the solutions to the following equations and substitute your solution to check for a and b. Okay, let's have a look at this first one. Here I've got 2x plus 10 is equal to 36. Now notice, there's a few things that are getting in the way of x being by itself. We've got this x over here, and we want to make sure that it's by itself on the left-hand side at the end. But notice, there's two things. One, there's this plus 10 that's in the way. We've got this plus 10 in the way. And not only that, we've got this 2 as well. We've got that 2 as well. There's quite a few things in the way. So what I usually like to do is I work from the furthest thing away from my x. So here, notice the 2 is right next to the x. I don't want to move that first. What I'm actually going to move first is this plus 10. So if we've got a plus 10 over here, well, what's the opposite of plussing 10? That's minusing 10. So I'm going to perform the reverse operation. I'm going to move this plus 10 to the other side and subtract. So here I'm going to have 2x is equal to 36 minus 10. I'm performing the reverse operation of plus 10 first. And so when I do that, I have 36 minus 10 is 26. And I've got 2x on my left-hand side. Now, I don't like to have 2x. I want to have just the x by itself. So what do we need to do? Well, if you remember from the previous examples, one-step equations, what we need to do here is we need to actually divide by 2 because this 2x just means 2 times x. And the way to get rid of a multiplication is just by dividing. So I'm going to divide both sides by 2. And by doing so, I cancel out the 2 here. And I have x is equal to 26 divided by 2 is 13. And that's our solution for this equation. what we can do is we can check our solution just like we did before. So our left-hand side was 2x plus 10. And so what we can do is we can replace x with 13. So let's do that. So I've got 2 times 13 plus 10. And if you perform your operations in order, we need to do the 2 times 13 first. So 26 plus 10. And 26 plus 10 is equal to 36. And that is what was on the right-hand side originally. So here, our left-hand side was 2x plus 10. Our right-hand side was 36. And so here, that's equal to the right-hand side, which means that this equation is true. Okay, so that's our first example here. What we want to do is, when we're solving two-step equations, is deal with the thing which is furthest away from our pronumeral first, and then move towards our pronumeral slowly, and perform those reverse operations, just like we did with our one-step equations. Okay. Let's have a look at this next example. I've got 5a minus 3 is equal to 12. So 5a minus 3 is equal to 12. Let's have a look here. 5a minus 3. Now, what is a thing which is furthest away from our pronumeral? We've got this pronumeral a. We want to make sure that it's by itself. Well, the thing that's furthest away is this minus 3. So what we want to do is we want to perform the reverse operation. The reverse operation of minusing 3 is adding 3. So I'm going to add 3 or move this minus 3 to the other side. So here this gives me 5a is equal to 12 plus 3, which just becomes 15. So 5a is equal to 15. And just like we did before, 5a is just 5 times a. So if I want to get rid of a multiplication, I need to divide. So I'm going to divide both sides by 5. So here I'm going to divide by 5. I'm going to divide by 5. I'm going to cancel these out. And so here I have a is equal to, well, 15 divided by 5 is actually equal to 3. And so my solution is a is equal to 3. Let's just sub it into our equation just to check that this is correct. So the left-hand side of my equation was 5a minus 3. Let's substitute a is equal to 3. So here I've got 5 times 3. I've replaced a with 3 minus 3. So that's 15 minus 3, which gives me 12. And if you have a look, that is indeed the right-hand side of my equation. So that's equal to the right-hand side. So that tells me that my equation is correct. Okay, so that's how we can solve two-step equations. Oh, I've actually got a third one here. Excellent. Let's have a look. Actually, no, it should be good. I'm going to leave that third example. So that's how we solve two-step equations. We first start off with the thing that's furthest away, so usually dealing with that number that's by itself first, and then we move towards our pronumeral. So that's how we solve one-step equations and two-step equations. Hopefully that was helpful, Year 8, and if you have any questions, feel free to email me or send me a message on Google Classroom. I'm more than happy to try and answer your question. Have a go at the questions, and I'll see you in the next video. Bye!